Welcome to our UAV workshop. Thanks ever so much for coming along. It's great to see a good number of people registered. I'm Matt Wood from the University of Gloucestershire. Matty is at the front here in the green t-shirt from NRW, and the reason we're here is because we'll all be aware of lots of rapid developments in the technology of using UAVs, using drones to either do research or monitoring with seabirds. And there's lots of papers going around the place and lots of interesting work happening, but we thought it was a really good opportune moment to get together and try and share some of this best practice, and to also help out guys like Matty and Alex Banks from Natural England. And do we have anyone from SNH as an equivalent, perhaps? Equivalent people at SNH or in Northern Ireland or in the Irish Republic, who are, when they are asked for permissions to give licenses to people to do this kind of thing, would really benefit from the advice of practitioners to be able to assess whether proposals are feasible, he says. Click the mouse. And you know, a lot of us are familiar with going to seabird colonies like this, you know, and if you were asked to go and count something like that, this is the gannet colony on Grassholm Island off Pembrokeshire. I'm not aware of anybody counting them with a UAV at the moment. But it's a tricky job. It's really hard to be able to count the number of individuals that are here if you're going to do it from a ground position. But if you've got this aerial view, then it makes things a lot clearer. But there are obviously a lot of challenges that come with this rapidly advancing technology. So what we're here to do today is to try and share that experience, to share that best practice that people are developing quite quickly, while having our kind of legislative requirements in the back of our minds for people like Matty and Alex. And also, after the first section of the talks, a few of us are going to get together and think about planning a review paper to be able to summarise the things that we're going to talk about today. That second part is not compulsory, by the way, don't worry. If you're looking around for the exits at that point, that's absolutely fine. The first section will be thinking about these little case studies where people are sharing the expertise that they've developed of using UAVs with seabirds. The first one, very kindly, is from Norm Ratcliffe, who can't be here today, but we put together a little video, so we'll kick off with him first. And his video is quite broad, a kind of user's guide, if you like. That video takes about 25 minutes, so we're going to try and, Matty and I are going to try and talk more quickly through our talks so that we can make time for that. And then we'll get back together in that best practice workshop to think about the kind of collating those protocols. It's great that there are people from different parts of the world. I haven't yet made eye contact with Kyle yet. Is Kyle here? His talk's loaded up. Hi Kyle. And George as well. We've got a sort of context from North America. Norm is quite experienced in, obviously, in Antarctica. And we've got interesting things that are starting to happen in the UK as well. So that's our plan for today. We've just had a last-minute entry as well. Andy Webb from, does he work? Is it HiDef? The guy, people who paid for a wine reception at some point, is that right? He wants to come in and squeeze in a quick 5-minute chat as well in that as well. So we'll see how we go. I think it's fine if we go over the 5:30 thing a little bit. Anyway, so there we go. Happy with the plan? Okay. Right, so what we should do now is get Norm out. Norm was very keen to be involved in the workshop. He's been involved in the Seabird Group over the years. And the reason he said he wanted to contribute to the workshop was that he said he'd had such a lot of help from the Seabird Group over the years through the course of his career. So I think it's really nice that he's paid it back. So I went over to Cambridge in July when it was ridiculously hot, and Norm's going to talk about a kind of user's guide as to how to get started working with the UAV. Parts of it are a bit dense, so just bear with him as he talks about the legislative requirements. But our aim is to count some seabirds in a field in Cambridgeshire. Okay, right, here goes. That video is unavailable. Backup plan, right. So I hope everyone brought popcorn, and there we are. Okay. Now, when I showed this to my wife, she said that looks like a bad version of a middle-aged Men in Black video. So please bear with us. We turned up wearing identical sunglasses, clothes, and even sun hats later. But here we are. So we're here at British Antarctic Survey, and Norm is going to be somewhere exotic on a seabird island when the conference is on. So hi Norm, wherever you are. Hi Norm.
Yes, I'll be on Tristan da Cunha, so it'll be lovely, but I'll be thinking of you.
But Norm's very kindly offered to share us his experience about using UAVs and seabirds, and that's great given his the work that he's done, and hopefully it'll complement the other stuff we're going to hear about today. So Norm, maybe you could just tell us a little bit about how you got into using drones to survey seabirds.
Yeah, sure. So I thought this was a really great opportunity to use technology and the emerging drone innovation that was happening at the time, and applying this to wildlife surveys. So there was some work on this, but it was very tentative. So a lot of the early equipment, the drones, they weren't very good. So they had limited capabilities. They were quite unreliable, they crashed quite readily. So yeah, we got into this and tried to develop some technology that would work, and some basic protocols that you can use to actually survey seabirds. And yeah, we had problems at the start. Some of the equipment did indeed crash drones in the sea, crashed in colonies, and it was really brutal at the start. Yeah, it was expensive, and it was frustrating, to be frank. But yeah, after 3 or 4 years developing piloting skills, and then this next generation of technology that's come along, which is much more reliable, and I think now there is real opportunities to do big scale surveys. So this last year we surveyed the whole of Cygney Island for chinstrap penguins, which is a big colony, hundreds of thousands of pairs on it, and yeah, we got a complete survey of all the sub-colonies right the way around the coast. So it's starting to change from just being proof of concept into a genuine tool for monitoring and conservation. Great. Okay, so we'll go up to your office and we'll look into the preparations that you need to do before you make a flight. Absolutely.
Then we're going to go out and count some seabirds in rural Cambridgeshire.
That's right, yeah.
And then after we've done that flight, we'll look at how to handle the image processing as well, which is one of the tricky bits because of the big volumes of data that get collected.
Absolutely. Yeah. Okay.
Right. Okay, so we're here with Norm, and shortly we're going to go out and fly the UAV, which is in the big black box over there. But there's some really important things that need to be considered before you start flying. Where would you start, Norm, when you first kind of are thinking about the steps of being able to go out and do some survey work with a UAV? There's some important stuff that needs to happen first.
Yes, 2 most important things are to fly legally and to fly safely. So if you're not doing those, you are at risk of injuring people and being responsible. So you could end up in court or with a jail sentence if you're not careful. So it's really important to be on top of all this. The legal aspects are outlined in the Air Navigation Order, and there's Articles 94. This is quite dull, I'm afraid, but it's really important. And the main rules are, you can't drop anything from your aircraft. So that would get you in trouble if anything was to drop from it. The person in charge of the aircraft can only fly it if reasonably satisfied that the flight can be made safely. So this is all about your judgment, but also showing that you have made those judgments. So it's often good to have a paper trail before you fly, that you can show that you've evaluated the safety of the flight. And you have to maintain direct unaided visual contact with the aircraft to monitor its flight path in relation to anything else, other people, aircraft, whatever, for the purpose of avoiding collisions. So unaided means without binoculars, so you have to be able to see it with unaided naked eye. And there's some more specific guidance that comes in the next Air Navigation Order section. This is the more complicated one that needs due consideration. If you're in charge of an aircraft which has a mass of more than 7 kilos, excluding its fuel, and for UAVs that includes the battery if you're flying one of these, so you can't say the battery is the fuel, it's the electrons that are the fuel, so they weigh nothing, so you can't just subtract the battery weight from that, that needs to be included. So yeah, and any article or equipment installed to it, so if it's over 7 kilos, you can't fly it in classed airspace, so near an aerodrome or an airport, unless you get permission from the air traffic control officer. Or Yeah, so that's one thing. And you can't fly at a height over 400 feet, again, unless you have permission to use that airspace. So most manned aircraft have to fly above 400 feet. So these are essentially trying to isolate manned aircraft from UAVs. And the other thing is, you have to be using these things recreationally and not for commercial operation. Then you can just fly them, but if you're using them for commercial operation, then you do need permission from the CAA. And this is quite a lot of work, so you need to have an operations manual for the organisation, and you need to be a certified pilot yourself, so you have to go along and get the RPQS qualification, which involves doing a ground school for 2 days and passing an exam, and then doing your flight assessment. You probably need at least 20 hours flight assessment to do that.
Don't have nightmares. It's not like that.
Before doing your aerial survey, one of the important things to do is a pre-deployment survey, just to make sure you know what you're going to be up against once you get out in the field. There's a few websites that can help with this. Have a look at this. So yeah, it's important to reconnoitre where you're going to be going. So Bing Maps is very helpful in this respect. So we're going to be going to Grange Farm in Napwell. This belongs to our SPB, and they kindly let us fly there. We see we've got a 1 to 25,000 ordnance survey map here, where we can see various details that are relevant to us. There is a power line running through the farm, which may create a hazard. There are roads and footpaths, which may mean we encounter things like pedestrians, dogs, vehicles. If we zoom out a little bit, we can see that there are various settlements. There's Bar Hill, Ellsworth, Papworth, Everard. So these are all in flying distance. So if we get a runaway UAV, it could easily access these areas, and Camborne to the south. There's a nature reserve here, so we need to be cautious of any disturbance to that, particularly if there's any Schedule 1 species there, we could be infringing the law. We can also have a look at the satellite aerial view. So it's Napwell. So yeah, we can see there's some quite tall trees planted in as windbreaks, so these could again create a hazard, but by and large it seems to be open farmland we're going to be flying over. So that all looks okay. We also need to be looking at the weather, so we need good weather conditions to do the flying. So today it's looking fine with some cloud, so that's okay. Have a look in more detail, particularly we're interested in wind speeds. So the winds are fairly light, so yeah, the drone needs to be flying in winds of less than 10 meters per second. These are in kilometers per hour, so this is very tolerable all day. So this is looking good for the survey so far. The other thing that you may be less familiar with is checking out on Sky Demon about various things to do with manned aviation. This is. So if we move up to Cambridge area, we can see these pink areas are basically air traffic control areas, so we shouldn't really be flying within those at all. Fortunately, our site is over here, so there's no problems there. We're outside any controlled airspace. We do need to be aware that there's various glider clubs, so you can see these green circles here, glider clubs and small aerodromes. And we also need to be aware of any notifications to airmen, NOTAMs. So if we start a new route, take off from Cambridge, and if we land at, let's say, Peterborough, and create the route. We can move this through all the various aerodromes in the area. find out if there's any notifications of low-flying aircraft or other air traffic control issues that might affect the area we're flying in. And all the NOTAM information's over here. So I looked at this earlier and there's nothing really we need to worry about. So the final things we need is to look at the NATS website. This gives you all the aeronautical information. If you go to AIP, General Information Index, Aerodrome Information Generic, we can find the phone numbers that we need for the air traffic control areas, so particularly Cambridge, so we need to get that. So yeah, we also need to find the phone numbers for the air traffic control in the area, so you can get this from the NATS website. You go to Aerodrome Index Specific and you have a list of all the different airports in the UK. We're interested in Cambridge. Textual data. You can see all of the ATC contact information is here. So that means if we get a flyaway, the drone starts to fly away towards the Cambridge ATC, we can get in touch with the air traffic control officer and notify him that there's a risk to aviation on the way to them. And that's it. It's all ready for our flight now. So we can go into the field and perform our survey.
Okay, so here we are at RSPB Grange Farm. They've kindly given us permission to fly here. And yeah, we're just going to fly in this set-aside field over here, so there's no crop to damage. It's fairly open, so if the drone does go down, we'll be able to find it again. So it seems like a suitable place to do our trial. The weather's great, nice and sunny, no sign of clouds or rain, light breeze, which is perfectly acceptable for the vehicle we're flying. Looking around, the pylons are a long way away, so there's no risk there from collision or electromagnetic interference, which could affect our aircraft. But one thing we do need to think about is probably turning off our mobile phones, because they can interfere with the signal. So switch those off.
And we're going to count some seabirds.
I'm going to count some seabirds, yeah. I've got mine.
Cambridge is famous for them.
Dear daughter's penguin toy collection. This is a emperor chick, so we'll distribute these around the field a bit, and then we'll do a survey of the whole field. We'll stitch it together, and then we can do a count of the penguins when we get back to the office. Great. Yeah, okay, so this is the airframe. Got 4 motors. These are all controlled. Batteries will slot in here. And then you've got various speed controllers, gyros, accelerometers, GPS, which basically control the speed of the different motors and how it flies in terms of pitch, roll and yaw. So and that's controlled through a handset, which I'll show you now. And here's the handset. So throttle, yaw, roll, pitch. We've got lots of buttons which control different aspects as well. And eventually, as you'll see, we'll have an iPad mounted on here which gives you all the flight data and images as it's collected. So it's a really very advanced piece of kit. Okay, so ready for takeoff now. One last check. Voice warning, take off. Step back a bit.
Pre-flight checks.
the bird. Gives you a wide spot and good resolution.
The production quality leaves a little to be desired. So what Norm's doing now is he's checking the UAV works and he's checking his camera works before he goes and does his flight plan. He's going to fly in a grid up and down the field where he's put all these little puffins. But yeah, you would think that that amount of noise would be very disruptive to a seabird colony, but we'll see later. It's not always the case.
So we're back in the office now, and it's time to process the images from our survey. I use something called Image Composite Editor. It's freeware by Microsoft Research, and this does the job very quickly. You can put a lot of images into here and it'll do a stitch. It doesn't require any geographical information, no GPS fixes. So it just uses patterns in the images to sort of create a jigsaw and put them together. And this works so quickly you can actually use it in the field just to check that you got all the imagery you need. Which is a lot better than getting back and finding you got a big hole or a wedge out of your survey and then having to go back to the colony at a later date to acquire images of there, by which time the number of birds may have changed. So it's quite simple. You just select the images you want to use. You should omit any during takeoff and landing because they'll be at a different scale due to the differences in altitude. So I'll just take those, open, and it'll open these, and then we can just tell it to create a panorama. So you go through the stitch, then you can crop it, and then you can export it as a JPEG. And this does take a little bit of time, you know, several tens of minutes, so here's one I made earlier. It's loading up the JPEG, and there we have it. So you can see the car there, and here is the plot that we surveyed. So the penguin toys are sort of along this strip here. And you can imagine if this was a large gull or tern colony, you'll be able to capture the entire area and do counts of birds within that. So that's the next step. So we need to put this into GIMP now, and we can start to do a count the dots procedure in order to do the survey. Okay, so we got our stitched image, so now it's time to start doing the count of these, and I'm using a program called GIMP. Again, it's freeware, so you can just download it off the web. It's a generic image editing package, so you can use it for lots of different things, but it does come with a contributed package that counts dots of different colours. So we're going to go through this now. So here we can see the image zoomed in, and there's different penguins. So the first thing to do is create a new layer. We don't want to put any marks on the original image. So create a new layer, select that, and then we can put dots. And now we can put dots on the penguins. So there's one there. Here, move down, another one there, and two little ones. You can, if you wanted to assume these were chicks, for example, you can add another layer and do a count in another colour. Then we go to the contributed, count the dots. You can get this from me if you need it. We need to use the exact same HTML code and say OK, and OK again, and there we go. It returns there are 8 dots, and I know there were 8 of Phoebe's toys that we put out in the field, so we have a successful survey, and that's all there is to it.
Well, thanks, Noel, for showing us through all that. It was really interesting to see the whole process go through. I just thought it'd be useful for the guys who are watching the video at some point, and you can't be along, if we could ask you a couple of questions in this virtual audience. So if you were starting off doing this for the first time and you wanted to have a go at doing some UAV survey work, what would you recommend people start out with? What's the first thing to try and do?
Fly. Just get a drone, fly it for hours on end. Every chance you get at lunch times, this is what I used to do. I used to just pop out for lunch, find somewhere safe you can fly. And yeah, you should basically know your aircraft and how it behaves and its controls. You should just know it backwards. It should just be second nature. And if anything does go wrong, you can immediately get control of it. So lots of practice. If you're flying commercially, obviously you need to go through the course as well. But before you can even start doing that, you probably need to rack up at least 20 hours flying practice to stand any chance of passing your flight school. So just make sure you're aware of the legal obligations, so you are flying safely and legally. Because if something does go wrong, it could be quite costly.
And it's clear that a lot of planning needs to go into these things as well. That you can't just open the box and go out and do it.
Yeah.
Is it? I'm trying to think about the balance of the planning and the flying and the image processing. Is it? I guess you just need to deal with each one in turn, don't you? Really, and kind of work with all of them. You can't. You can work with specialists, maybe. You could work with other people.
So it's sort of a chain of events. But yeah, I think the thing that people tend to skirt over is the planning and the basic knowledge of the legal framework. They just tend to want to get the drone out and fly it. And you should really sort of think very carefully about the planning phase before you go out, because that will minimise the risks to your aircraft, yourself and anyone around you. So those are really important. And it's easy, you get a nice day, it's been horrible weather for ages, you get that weather break, you just want to get out, but just make sure that you do the necessary planning. I mean, in the courses they talk a lot about situational awareness and airmanship, and that is fairly fundamental. It's making good judgments all the time before you fly and during the period you're flying. So that's fundamental to being safe.
Okay. And my last question is, what will you be doing in September?
In September, I won't be using drones. I'll be working on northern rockhopper penguins, and they're nesting beneath tussock grass at 7 foot high. So, if you flew a drone over the colonies, all you would see is green. So I will be actually crawling around on hands and knees, which is quite the antithesis of doing aerial surveys. I'm looking at breeding success relative to a traditional egg harvest. So I'm trying to develop a sustainable egg harvest for the Tristan community. So it's a wonderful island. I'm looking forward to doing some work there. I won't be taking this with me. It's just
No. Well, we'll be thinking of you.
It'll be a big paperweight, basically.
Great. Well, thanks very much for your time today, Norm. It's been really good. Appreciate the time you put into it.
Thank you very much. Thanks for the opportunity.
Cheers. Right.
Can you say I was in a hurry to get back? There you go. That was all kind of done in 36-degree heat in our kind of heat wave summer in the UK this year. So Norm's can obviously still make his brain work in the heat when I can't. But there you go. So I hope that was reasonably useful as a guide to an overview of the process there, if you like. Some of it is quite dense. There are issues around that recreational versus commercial use. As soon as you become a commercial, as soon as you start making money out of this, then you start to need all the kind of permissions that Norm was talking about. And as I understand it from talking to my colleagues at work, is that when that's done for research purposes from a university, that comes under a commercial use, rather than saying it's research, it's different, nobody's making any money out of it. So I think it's important to check in the regulations for sure. That UK Air Navigation Order, for example, contains a specific section about UAVs. I'm sure there are lots of differences in different national jurisdictions. But all this stuff is generally quite tedious to get through, but I think it's really quite important because there are obvious risks of this going wrong, of you having risk to some animals or people. But also you might want to think about the reputational risk as well. If you're the one to be seen crashing your drone into a playground or into, a colony of penguins, I don't know, that's what crosses my mind when I'm seeing these things buzzing around. It wouldn't end particularly well. So I'd encourage you to look into the regulations and persevere, actually. I think, you could watch that and be put off, or you could watch that and think, well, Norm's done it. Why not? Let's give it a go. Okay, does anybody have any additional questions from what Norm's done there? This will be available online if people want to watch it again, if you can't get to sleep. Sure.
How internationally applicable are some of the restrictions you talked about?
I think the regulations are going to be different in every country. These are specific to the UK, not just the European Union, for example. But I think the principles are the same, because the aim of them all is to, and Norm talked about it briefly, is to separate manned aircraft from unmanned aircraft, because that's obviously that is the primary risk that our legislatures are concerned about, I would think. They're more worried about you hitting a plane than you are about crashing it into some penguins. Yeah. Okay, right. Let's get our next speaker out. Do you want to use the microphone, Matty, or are you okay?
I'm probably all right, I think. I'm told I'm loud enough.
Yeah? All right, there you go. And still recording. Great.
Hi everybody. Is there right, it doesn't have the note. There's no note. Is there a note bit at all on here? Can I get that up? Have I foolishly thought that I could?
I think there is a present. There is a. Who knows how to do this?
So they're down. Yeah, they're in there.
Yeah, but if you press show. Yeah, but.
Right.
Use presenter view. It says it should be working.
Maybe try it now.
No, it's not, because that should be a different screen.
Yeah.
You can do it that. I'm sure nobody will mind. Let's just do it the other way. As long as you don't mind the video showing your notes.
Okay, hiya folks. Okay, my name's Matty Murphy. I'm Senior Ornithologist with Natural Resources Wales. I'm going to give a talk about the different legislation aspects that we have to consider with many different things, but including drone work within Wales for myself. So I've got to talk about UK legislation, European legislation, and then give a little case study at the end where we had to go through all of these different aspects. No.
Click on slide 3.
Slide 3.
With your cursor. That's it. Do you want to do it?
Yeah. I'm doing it this way, aren't I? Of course. Yeah. Okay. So with UK legislation, we have the Wildlife and Countryside Act, which you have these various different things that you're not allowed to do. So intentionally kill, injure or take any wild bird, intentionally take, damage or destroy the nest of any wild bird, intentionally take or destroy the egg of any wild bird. And then we have Schedule 1 species, which is species such as roseate tern, little tern, black tern, Mediterranean gull, little gull. And it is it's an offence to intentionally or recklessly disturb on or near any of the active nests of these species. So here we have a map of Welsh SSSIs. So these come underneath they're created under the Wildlife and Countryside Act, and so they're European legislation sites. And just a few examples: we have a little tern colony up at Gronant. We have Carragher Clam, which is some large seabird cliffs, which is a SSSI for the feature of guillemot, and Flatholme down in the Severn, and that is a SSSI for lesser blackback gull. Next we go. Each one of these SSSIs has a set of criteria called the potentially damaging operations. I think they've got old now, but that was the name that we used to use. And effectively, when anybody suggested what to do something like the SSSI, we would look down this list, this PDO list, to see whether any of them are on there. And if they are on there, then they need consent for it to go ahead. As we can see, use of craft likely to disturb nesting seabirds is on there, which could include a drone. So my next slide shows, we're going on to European legislation, EU legislation, and this shows the different breeding seabird SPAs that we have within Wales. So we have Puffin Island at the top there, just off Anglesey, and that is an SPA for cormorants. We have Anglesey Tern SPA, which has an extension out in the sea for the foraging terns, and that is for sandwich, roseate, common and Arctic tern. We have Glenaberdallen and its Entley SPA, which is an SPA for Manxire waters on Bardsey Island, Grashome for gannets, and Skomer and Skocum and the seas of Pembrokeshire for quite a number of different seabird species, but you can see Manxire water and Puffin there. Now, the SPAs, like I said, they come under European legislation, and they have an environmental assessment under EU law, which is called the HRA, which we have to do to assess a plan or a project which may have an effect. And we have to ascertain whether that, alone or in combination, may have an adverse effect on the integrity of the European site, the species that are on there. Now, this includes big casework, such as things I've been working on, such as Wilver Nuclear Power Station, Swansea Bay Tidal Lagoon in the middle there, or a large wind farm like Wintermore. But it can also include smaller things, such as experimental field work and smaller plans or projects as well. So I'm now going to go into the case study that we have. So I mentioned Puffin Island before, which is an island just off the north-east of Anglesey. So it is, as I said, an SPA for great cormorant, but also a triple SI, because generally these SPAs are underpinned by UK legislation as well. It's a very important colony for seabirds as well, with large amounts of auks and different gulls, cormorants and shags on there as well. So, John Green, who's organised the whole conference, and Jess, it's Jess's masters, they wanted to count the cormorant colony with a drone. So we went through the whole procedure in a way what Norm was talking about. So we had to look at, did it need a Schedule 1, did it need a licence, as in, would it going to affect any Schedule 1 species? And it wasn't, so we went past that. But then we looked at the PDOs, and as we saw previously, there was use of craft likely to disturb nesting seabirds on triple SI, and as that leads to needing a consent, because of that PDO, we then had to go through a HRA procedure to see whether it was going to have an effect on the European site. So what I then did was I looked around the literature and different areas to try and find something where people had counted cormorants with a drone before, because I'd come across different aspects of work which would involve a similar species but somewhere else in the world, or a different species like auks or gulls, but I struggled to find cormorants. But in the end I found something which pointed me to David Craig of the irishsites.com, a drone pilot in Northern Ireland, and he had counted a colony in Stranford Loch, and he basically explained how if you kept it 30 metres above and you hovered it, then the birds were accustomed to it, and 30 metres you could go and do a grid over it and the birds wouldn't notice at all. So what we did was we put that in as a stipulation to the consent, but we also said that what we needed to have was an NLW member present, either on a boat or on the island, so we could check to see how the cormorants behaved, so we could learn from what was going on as well, so that we could, you know, use it again. Okay. So the added complication was the BBC were involved. Originally, John had wanted some students from Liverpool University to build their drones and then fly it over, which, as Noel was pointing out, could be a bit dangerous, because he pointed out has the older ones would crash into birds and things like that. But they had exams at that time. So John, who'd already talked to the BBC about this, eventually figured out that the BBC could do the flying for him. But when we had the BBC, then John had to explain. We explained to John what needed to be done, and then John explained to the BBC what needed to be done. And at times they weren't that happy about it. They were a bit... They wanted it their own way, but they did follow it in the end. So this is a picture of them on the boat, and they're just sorting out the small drone to take the sweeping pictures to start off with it on the whole of the narrative, as it were, which nearly got lost as it went away. They all panicked, and we had to drive quickly towards it. This is taken with my brilliant camera. That's the BBC there, and that's the drone, and they were following the guidance. It was 30 metres above the colony, which is just below them on the cliffs coming down. And I was communicating with John via walkie-talkies to explain that there was no reaction from the birds and everything was going fine. These are some of the images that they collected. Jess was telling me that they had problems with blurring of images where they stitched them together, and here's some kernel densities of the nest that they collected. But on this one, this shows areas which were missed. So what Norman was talking about, where you have in there, you have your computer in there, and you could check that you covered everything. And obviously that wasn't done, and so they have some areas which were missed, and therefore they didn't count nests in that area. But what we found was we counted it the day after on the boat count that we normally do, and we got 476, and their count came up with 591, even though they missed the areas. So we do have an increased amount of area, increased count on the nests there. So my closing things would be, if you've got to do some work within the UK, apply for your licence, you're sent early, so that we can talk with you, people like myself and other relevant experts, and we can get it right, and we can get the licence or the consent right, and then we don't have to go back, because they can take 28 days to get these things processed, and you might miss your breeding season. And thanks for listening, and any questions? Although they're there, some of the answers.
Anybody have any questions for Matty?
All of these are involving actually counting dots by hand at the end, is that correct?
So that was done by Liverpool University, but I think I'm not in on what they did. You see what I mean? They gave me the answer, effectively, but yeah, I mean it counts, counting dots at the end. Yeah.
It's not a marvellous programme that counts them all.
Well, I see Norm's programme didn't look that great, did it? Because he had to go through
He had
You just mark off and
a
put
few.
how many red dots and how many green dots, etc. So all your actions just marking.
Okay, and then it adds them all up.
Yeah.
Yeah.
So you are counting them by hand.
Yeah.
Stay tuned.
Yeah, okay.
Who would you like? I think that was a marginally hand at first.
Go on, Ryan.
I was just asking, how did you ascertain the 30 metres?
By talking to this drone pilot, basically. But we also had the belt and braces thing by being out there. So
Was
if...
it just by eye, or did you...
Oh, you mean by ascertaining it? No, you were just hoping they were doing it. I had no way of checking from the boat that they would...
I just meant, as in, is there a measurement device on the drone?
Oh, no, it'll be on the drone. Sorry, I thought you meant me. No, it'll be on the drone. It'll tell you how high it is. Is that right, Matt? You've used drones? Yeah.
Yes.
Yeah, so it'll tell you how high it is.
It has quite a good GPS in the drone itself, so it will have a very clear idea of how high above sea level it is. You just need to know how high you are above sea level to account for that. But yeah, it can tell the difference. Sorry.
Yeah, just wondering how long the whole thing took, using...
It took the whole thing took a day, but that was because they were making a film.
Right.
It all got it all got condensed down to 4 minutes
So the supplementary
on the
question,
one
yeah.
show, effectively. So how? I mean,
How
that
long
did.
should it have taken to do the survey?
I don't know. To tell you the truth, but I mean, it did. Oh, what? Because they tried one thing and then they seemed to try another thing.
Yeah.
And so, if you knew what you were doing, I think, yeah, it'd probably take the same amount as if you were counting them from the boat, but you are getting the ones which are higher up. Because we're counting them on these cliff faces, and they're always the ones which you're not going to get, and those top ones. And certainly, I think when the colony was first, its conservations were created, it has a land count in that conservation objective which goes towards it. Whereas we've always been counting from the ship, and we're always a little bit below because we're never going to catch those ones.
Okay, I think it's great there are more questions, but we're going to have to try and keep to time, so I'm very sorry to cut Ellie down. Grab your speaker afterwards or in the coffee break, and then we'll good sign if there's more questions than time. Was it Robin was up next, is that right? Is that sure? Yeah. Great. I'll show you little time markers from the front. So look at that.
Sure, yep. Hi, many thanks. The UK's largest mainland breeding seabird colony is estimated at 149,000 pairs, and it's in northwest England, as you will see. Oops, hopefully that didn't delete. Oh yeah. It's in northwest England along the Flamborough to Filey coast. And Liverpool's marked up there for those who are not so familiar with the UK. The colony is comprised of 13,000 pairs of gannets, 51,000 pairs of kittiwakes, 20,000 pairs of razorbills, and 60,000 pairs of common guillemot, and some gulls, herring gulls, and one or two other species fulmars. Oops, no, it doesn't work. Traditionally, the colony has been counted visually from boat and land. Surveying from boat is reliant on favourable sea conditions, being available for 3 to 4 days. Within a 1 month period, that is where the recommended census period for each of the key species overlap. It is, however, unusual to get 3 to 4 days of favourable sea conditions to allow a complete count of all species within a given year. Also, surveying from boat can be a challenge, challenging due to the observers almost always being in a state of motion due to the sea swell, whilst trying to scan a cliff, which is up to 135 metres tall, where the topography of the cliff can obscure visibility of the breeding birds. In 2016, NIRAS was funded by the offshore wind farm developer Ørsted, previously known as Dong Energy, to conduct a proof of concept trial in the use of drone captured imagery to count cliff nesting seabirds. The trial was conducted within the representative sections of the colony at Flamborough Filey coast. It set out to establish the optimum camera and drone parameters whilst ensuring disturbance to the breeding seabirds was avoided and collision risk was minimal. Success of the trial were dependent on obtaining imagery of a resolution sufficient to distinguish between species, whilst disturbance to breeding seabirds was avoided. Potential operational challenges confronting the trial were surveying cliff whilst maintaining a direct line of sight between pilot and drone. As Norman mentioned in his original talk, that's a legal requirement for the basic drone flying pilot. You can go to more advanced drone flying and not have legal line of sight, but you start off having that. There's also the challenges of in-flight turbulence to the drone from local updrafts, or downdrafts I suppose, around the cliff environment. And there's obviously the risk of bird collision in a crowded airspace with 49,000 pairs of birds flying around, or some of them anyway. The drone we used a 1 metre diameter microcopter, which has got 8 props, which was carrying a digital camera, specs up there, with 24.2 megapixel sensor and a 22mm lens. The drone was piloted by a Civil Aviation Authority approved pilot, Simon Stickland of Dragon Eye Filming, and that was because this was a commercial operation. We were being paid, and therefore you have to have a CAA approved pilot within the UK. NIRAS, my employer, we have a drone unit in Denmark of 5 professional pilots with masses of drones. They actually advise the Danish government on flying drones, but it takes months. It's not a quick procedure to get your pilots from another country approved within the UK. And we only had something like 3 months, I think it was, to get this up and running once we got approval. And so it's far more effective for us to use a UK CAA approved pilot. So one of our guys from Denmark came across Soren to work with Simon Stickland in flying the drone. And the other very important thing is that Flamborough Filey coast is a special protection area. In fact, it's a proposed special protection area along the whole length of what we were surveying, and that we needed consent from Natural England as the statutory nature conservation body in England to be able to fly during the breeding season. It's also an SSSI as well, which UK law, which again requires consent from Natural England. It's also an RSPB reserve, and we got a lot of help and consent from RSPB to undertake this work. We took a progressive approach to monitoring disturbance. It was agreed that if there was disturbance to breeding birds, we would just abandon the survey. Disturbance monitoring was conducted during the flights by trained RSPB staff and a NIRAS ornithologist. Poor weather pushed back the survey flights to the 29th, 30th of June in 2016, but given the delay in the breeding season that was occurring then, the timing of the survey was still deemed acceptable to meet the aims of the trial. Flights were conducted at distances to the cliff of between 15 and 50 metres when trying to establish the optimum operational parameters for undertaking digital photography. Oh, sorry, should have moved the slide there. Let you quickly have a look at that. The only bird drone interactions observed during this trial were when the drone was mugged by a breeding herring gull. The drone survived and the bird was totally unharmed. There was no contact made. There was potential disturbance of a club site of non-breeding gannets, and there's a question over whether that actually was the drone or not, but it was observed twice. And there was a fulmar which flew very, very close, worryingly close to the drone, and showed no evasive action at all. Actually, additionally to that, I've also seen kittiwakes when they were pulling grass off the top of the cliff top to take down to their nests. They were also flushed out of the system when the drone immediately took off. And certainly a lesson is to actually, I suppose, think like a bird, as we should do as ornithologists anyway, and approach from afar. So as soon as I saw the kittiwakes getting up, I realised what the issue was there. The drone was giving them a quick surprise. It was just suddenly appearing. So fly from a distance and approach, so they get maximum time to see the drone approaching, and then they stay on the ground, no trouble at all. During the trial, the density of birds in the airspace was observed not to change with the presence of the drone. It is not possible to say whether there were zero disturbance of breeding seabirds, but what we can say is that there was no witness disturbance to breeding seabirds. Optimum operational parameters for the drone when capturing digital still imagery for counting cliff nesting seabirds includes, or we determined was to fly between 35 and 50 metres from the cliff face, and the vertical flight paths were spaced about 20 to 30 metres apart with the camera system setup we had. And the digital, the drone captured imagery was found from this initial trial to allow identification to species, such as the accurate separation of guillemots and razorbills, the distinguishing between non-breeding and breeding kittiwakes, following census, published census criteria. Sorry, that's, yeah. So we've got imagery such as that. Following on from the success of the proof of concept trial in 2016, Orsted funded NIRAS last year to trial the use of drones in counting the breeding seabirds along an 8-kilometre stretch of colony identified by RSPB as challenging to the observers when counting. This was conducted over a 5-day period, followed by a 6th day when an attempt was made to compare the efficiency of drone-based versus boat-based observer counts at the same sections. This second trial encountered additional operational challenges to that in 2016, which included visual perception of distance between drone and sea surface, drone and cliff, difficulty in positioning drone to the survey section, poor GPS section at the base of the cliff, basically from sea level up to 80 metres in places, and loss of satellites, and therefore the drone enacted its go home. Unfortunately, on one occasion, that go home meant hitting the sea stack, so we had to try and recover that drone. And that's another lesson, always have a spare drone. We had 2 drones there, 2 operators flying. We had no spare drone. The Manchester Arena disaster happened about a day before, and we had to get a drone from Denmark. It took us 4 or 5 days because of security clearance to get it into the country. Poor image exposure was another issue we had, a consequence of sun glare and shade when viewing in the south-southwest direction. The north-east coast people think is running north to south, it's not. So the drone was a lot of the time looking into sun, which when you got towards the cliff top, you suddenly got the sun blazing down into the lens. And finally, we actually found that was a slower rate of survey coverage than anticipated from the 2016 trials, partly as a consequence of the technical challenges mentioned. As a consequence, the imagery from this second trial was found to be inadequate to contribute to a census, as was planned, and for a comparison of the effectiveness or comparison between drone-based versus boat-based observer counts of the same sections. What the 2000... Sorry, I'm not keeping up with the slides here. Oh yeah. Back. Yeah. What the 2017 trial has demonstrated is that any future attempt to use drones in the counting of cliff nesting seabirds along the Filey and Flamborough coast needs to take account of sun glare and shade through timing of survey and adjustment of camera settings. That 8 kilometres is not a practical survey extent. Drones need to be equipped with rangefinders and real-time viewing, and that it is more effective to survey from a boat in terms of safety of the public, assessing position of the drone from cliff face, and visual line of sight in terms of hazard awareness. And what the two trials have shown us is that it's not practical or cost effective to use drones to survey the whole colony due to the challenges of stitching and counting birds on many photographs produced, as well as the other technical challenges I described. It may be concluded that the most cost-effective way of counting the whole colony is likely to be a combination of boat and land-based observer counts, boat-based photographs of low cliffs of about 400 from 40 metres upwards or downwards, drone-based photography of the upper sections of the cliffs at about 90 metres and over, but that aspect still needs testing to show it works. We've still to compare efficiency of drone-based, boat-based observer counts. Finally, there is a need for some work to determine how we can use drone and boat-based observer counts for the high cliffs, which to avoid duplication, i.e. where does your visual count stop and where does your drone-based count stop. The cost and resources involved in use of observer in whole colony counts of Flamborough and Filey coast is high and highly dependent on weather and sea conditions. It is highly desirable to continue investigating the use of drones in the county of cliff nesting seabirds, is my thought. It's a great team effort, and I thank all these people and many others who are involved in this project, which hopefully we can continue into the future. All right, thank you.
Does anybody have any questions for Robin? Yeah, Pat?
Fascinating talk. I was quite interested though to see what your definition is in terms of disturbance.
Well, you had the site manager and other RSPB staff who are very familiar with how the seabirds were reacting. So basically they detect anything that's detected which was abnormal. It's basically disturbance. Or obviously if it was mobbed as well.
So could you expand on that to say whether guillemot, for example, became more alert or agitated?
No, that's why I said we couldn't actually say there definitely isn't any disturbance, because it could have effect. I mean, as I think many of us know, what you visually perceive, there may be something underneath, like heart rate change, etc., which may then have a consequence on breeding success. No, we didn't measure that. And even though breeding success is being measured at the colony, the study wasn't set up to use those data to actually monitor.
Because I was just wondering whether the course of today's workshop and beyond, there is a need to have some form of standardised definition of what disturbance means.
Yes.
To a seabird.
Yeah, no, sure. I totally agree. Yeah.
Just like to say, out with the NIRAS trials, we also, I work at Bowland Cliffs, we flew a Phantom 2 drone near the cliffs, some of the lower cliffs, along some ledges of guillemots.
That's a fixed wing.
No,
Is it?
it's those small commercial drones that are
Okay.
like really common
Yeah.
drone that you see. And you can fly it along a ledge of guillemots, say 10, 15 metres back, and they didn't even look around. It's just another one thing flying around.
And I think you're coming back to stress, I was going to say stress, the pilots. We had two very, very experienced pilots correctly, and they found it highly stressful.
Oh, right, okay. They found it difficult,
Yeah.
so they would have benefited from time to practice
Yeah.
in that environment.
And they fly in central London, where there's strict controls and everything, and they still found it difficult.
Interesting.
Yeah.
Okay, they'll be really used to that. So definitely starting to get into some of the really useful thing that we'll talk about in the work in the discussion. Great. Great, thanks very much, Robin. Who's number 3? It's not me, is it? Don't save. Oh no, Robin was number 3. It's me. Oh right. Yeah, you can have the shouty stickers. Okay. Right. I'll try and talk quickly. Okay. So this is about some work that we did on Skocum Island in Wales, off the coast of Pembrokeshire, and there's quite a large lesser blackback gull colony, and it all came due to the fact that I used to share an office with Lucy there, my colleague. Lucy's a geographer and knows a lot about using photogrammetry to measure movement of glaciers and things like that. So it's one of those happy coincidences of working in a university that's small enough that you share an office with somebody who does something totally different. So anyway, that's my thought about coming to a big proper university. There you go. So can drones count gulls? Well, the first thing Lucy would like me to say is that it's not a drone. It's an unmanned aerial vehicle or unmanned aerial system. I'm not too hung up on that, but I think it's drones are things that are kind of automatous things that drop bombs on people, Lucy would say, but obviously it's a lot more, trips off the tongue a bit more easily. And can we use a UAV to count some gulls? Well, fortunately, spoiler alert, the answer is yes. So whether we were looking in open grassland gull colonies, or whether we were looking in more rough grassland or kind of deeper vegetation where there's bracken and bluebells, might not be particularly convincing, but in each of those habitat types we were able to collect imagery of sufficient quality to be able to count the gulls quite easily. So we could have used Norm's spotting technique here and counted the dots, would have worked quite effectively. And even if they were tucked away a little bit, if you were to zoom into that image in more detail, you'd be able to see little heads popping up in between the bluebells and the bracken. It's very important that we do count these gulls in this particular colony. It's a EU special protection area. There's all sorts of. It's got a long list of. It's got a long list of designations as to why it's an important place for seabirds. But also, the gull colony is in a bit of trouble. You might say, well, it's just returning to the low counts in the early 60s, 1970s, but back then people were eating the eggs, so that doesn't happen so much now, and the population has crashed down from, say, 20,000 plus down to lower than 5,000 last year. So being able to have these more accurate population counts as the colony starts to dwindle is obviously quite important if we're going to start asking questions about why. And I think that's an important backdrop to have. I'm here as a kind of relatively unskilled individual when it comes to UAVs, but as a seabird ecologist, I'm very interested in identifying these patterns and exploring why. So off we went to Skocum Island, a fantastic place if you get the chance to go and visit. Accommodation's all just been renovated in the last 5 or 10 years, but that's enough of the advert. And it's got a reasonably large colony of lesser blackback gulls, not so big as neighbouring Skomer Islanders where those data came from earlier on. So I guess I've already answered the question about whether you can use a drone to count some gulls. The answer is yes. But we were interested very much using Lucy's expertise to try and think about how we could do that more effectively. And it touches on the question that was asked earlier on about whether we can start to automate the counting process to some degree. So I'm going to talk a little bit about making sure that we have a minimal amount of disruption to the colony, then talk about this automatic image processing, semi-automated image processing, strictly speaking, and then talk about some preliminary results we've got about whether we weren't aiming to do this, but we had a little play to see whether we could separate herring gulls and greater blackback gulls that nest on the island as well. So that's what normally happens. There's me modelling how you would count numbers of nests, waving my stick around so that I don't get attacked or defecated or vomited upon. You walk through the colony and you identify the nests that have eggs. And then you might correct that count, use that more accurate count of colony occupation with a correction factor to correct your eye counts for the actual number of nests that are more likely to be there. If that makes sense. It's a very standard thing that you could do. I guess you could use a correction factor to correct drone counts on a cliff with boat counts, for example. It would be something that we're pretty familiar used to doing. So we were trying to minimise the disturbance that we impacted on the colony, and we wanted to separate the two roles. One is the pilots obviously got quite enough to do in trying to survey the colony and keep to the grid, which we haven't really shown graphically in an image, but we try and fly a grid so that we get lots of overlapping images to enable that composite to get stitched together. And you need somebody who's dedicated to looking at watching the behaviour of the gulls, and the drone pilot isn't necessarily skilled in both of those two things, and even if she or he was skilled in doing both of those things, they physically haven't got time to do it. It's a really quite time-consuming thing to do. So the protocol that we developed through a bit of trial and error and through our experiences as we continue the survey around the island was to approach from further away, as Robin mentioned as well, at least 50 metres away, to try and fly as smoothly as you can, so any changes of altitude, you'd want to make sure that you do that to the side of the colony. And with that angry swarm of bees that Norm was flying around in a field in Cambridgeshire, that kind of change in the note of the drone is something that can upset the birds, we found. We also found that the birds got less and less rattled, they were less and less disturbed the more times that they'd seen the drone flying around. So the very first sub-colony that we surveyed was a bit spooked, but subsequently they became less and less cross, and I think that's because they've seen their neighbours being surveyed, and it's a very open visual environment. They can see that that's not caused any particular harm, so they don't associate it with a predator response as time goes on. But if we took a high pass over the island to do a 50-metre altitude flight in order to make a composite image of the whole island, and we noticed that after we'd done that, the birds were much more relaxed. So we don't have data to explain these things. But I would think that's a really important thing to do, is to approach from afar and survey your area so that you know what you can see from a higher altitude the area that you're going to survey. We also established a maximum height at which we could fly and to get an acceptable amount of image quality. And we did that by lowering altitude to the side of the colony and then repeating transects across until we saw a response, until we got to a height where, from looking at the imagery, Lucy was happy with the imagery basically. And we got down to as low as 50 metres above the surface elevation without that many birds being disturbed. So that's half the height that Matty showed that image. I wish I'd taken a picture like that of the drone really high up in the sky and the BBC down on the ground. We were at half that altitude. The birds were sitting tight. They could note that the drone was there, but we didn't see any mobbing reactions unless on one occasion we went lower. We asked for permission to do that, and because we saw an immediate change in the response, we decided, well, we don't need to do that, and we wouldn't recommend doing that any further. So when I say minimising disturbance, this is minimal disturbance. This is what we're talking about. So there's the drone, there's the UAV flying over the subcolony. A bird goes up to it and thinks, oh, I'm not as bothered as I thought I was. But now, hey, Lucy's happy. I'm happy. So now it's over the colony at 15 metres. You can hear skylarks singing, you can't hear gulls getting annoyed. Some birds are moving around, some of them hop around the colony, some of them fly and go away, and so we use these videos to quantify that with behavioural response to see whether there was a difference in the behaviour of the birds during the survey and before it as well. But when there's a bird that's gone up calling, but we're not seeing any of the kind of free-for-all, if you like, any of the really acute responses that you might see when you're doing the walkthrough count. So we compared the number of flights on the left and the number of hops on the right, where they're hopping from one part of the colony to the next, or whether they're spending more than, I think it was 10-15 seconds in the air. And there's no significant difference either before or during the survey, although it might be getting there with that one data point up there, but there you go. So that video we showed you, I was expecting to see something more like this if we were flying at 15 metres, and I'm sure that might have been most people's impressions when they first heard about the idea of surveying gulls with a drone. Importantly though, we still need this technique to be able to work out whether any of those nests are occupied, because we don't think it's appropriate to fly the drone low enough to encourage the birds to leave their nests so that we can count the occupied nests. So if you want to do productivity calculations, if you want reproductive success, you're still going to need to be able to visit the nests. So there we go. That's about minimising the disturbance. Stop. Way off, all right, it's not stop, okay. So can we make this more effective? Once we've got our composite image and we've smoothed out all the lumps and bumps in it, we've ortho-rectified it and stretched it back into the way that we've, to make it more, to kind of do the thing that Norm talked about. Can we automate this process of counting the gulls? So we used what's a GIS software to undertake this supervised classification, where you basically take a training set of the spectral signatures of points of interest from your aerial photography. So you essentially tell the computer, this is a gull, this is a gull, this is a gull, this is a gull's head, this is a gull's back, this is a gull's head, this is a gull's back, this is not a gull, this is a gull, and you carry on that process until the classification, that process supervises the classification of the imagery such that you're able to ask the computer to count the numbers of gulls on imagery that you've not yet supervised. Okay, so you're giving it a training course, if you like. It doesn't have to automatically know what a gull looks like. Now, the difficult thing about that was that things that are quite similar to the bluish, slaty grey black of a lesser blackback gull are things like some feces on a rock or patches of flower. Basically, their own feces is pretty much the same colour as their heads at certain times. And the bluebells sometimes confused the spectral signatures. So we went through a process of refining that training set of being able to pick up just the optimum spectra of light wavelengths that were best at distinguishing between a rock covered in some bird shit and an actual gull. Okay, so yes, we were able to use these semi-automated counts up to a point that they were very highly correlated with the stick a dot on the picture, the manual count procedure that Norm was talking about earlier on. If you can sense that I'm at the limits of my knowledge base, then you're right. If you want to know more about this, you can read the paper that should be out quite soon. Now, an unexpected bonus of this is that once Lucy and Graham, the master's student actually who led this project, were looking at the imagery and saw greater black-backed gulls and herring gulls, they started to think that there might be the potential to use some of the differences between these gull species to be able to see if we could semi-automate the species recognition process. Their nesting ranges overlap to a certain extent on Skocum, that herring gulls are a bit more coastal and greater black-backed gulls prefer to be on the high bits around in the middle, but they are pretty much mixed in together, even though lesser black-backed gull colonies are quite discrete and separate. So we had some of the imagery to be able to test this, and it's the colour of the mantle is the thing that is most likely to distinguish the imagery of these guys. So this is one of those, as you can clearly see, figures. But if you ordinate the spectral signature in the blue wavelength and the green wavelength, you can start to separate out the lesser black-backed gulls in red, the great black-backed gulls in blue, and the herring gulls there in yellow. So that's a really quite a promising approach, given that we didn't go out, we haven't got that much data on great black-backed gulls or herring gulls to be able to do this. That's something that we're exploring at the moment. So in summary, we'd say that it is feasible to use UAVs to survey breeding gull colonies. You don't get large amounts of disturbance even if you fly at 15 metres above the colony, but fortunately, although we're automating a lot of this process, we still need ornithologists to be present to be able to guide this kind of work. The semi-automated image processing has got real potential to speed up and give the potential to cope with large areas of seabird colonies, and there's a lot of this kind of potential for species recognition techniques to work as well. So that's really, our hope is that that will unlock the potential of all these large volumes of data, large volumes of imagery that can be collected, and that technology is only likely to become more developed in the future. So if you want some more details, then we didn't quite pay the publication charging time for it to be out for this week, but there you go, it's out soon. Thank you very much.
I think you've got one question. As you, anybody?
That's all right. We can shift along. There's some water there if you'd like some.
Thank you. Hi everyone. So I'm talking about something quite similar to Matt's, but it's probably not as conclusive as what Matt's found. It's some kind of early thoughts on our experiences of trying to use UAVs for gull monitoring, and a whole load of questions that are really welcome input to. So I'm this Alex, I'm the ornithologist, and my colleague, the other Alex, is Earth observations scientist. So we have in-house drone pilots and UAV specialists within Natural England. So part of Natural England's remit is to monitor protected sites in England, and the two I'm talking about today are not a million miles away from here. So this special protection area in Lancashire called Bowland Fells, which has a lesser black-backed gull colony in it, and just to the south, a smaller area, well, a smaller gull colony, black-headed gull colony at Belmont Reservoir, which is part of the West Pennine Moors Site of Special Scientific Interest. So why are we interested in UAVs? So as I said, part of our remit is to make sure protected sites are monitored and well managed. So there are pragmatic reasons. So in an age of shrinking resources, to be blunt, it's sometimes cheaper and logistically more straightforward to send out a drone with a couple of pilots than to assemble a whole team of ornithologists. We obviously still need them for some questions, but realistically, that is one of the reasons why we would look at technology like this. Matt's already mentioned the disturbance angle, so obviously these are protected sites, although disturbance may only be temporary, obviously we would try and avoid that wherever possible. And we also have published evidence standards which set out how we're going to do things, and we're always trying to improve those. So there are objective reasons for doing this, as well as the more kind of subjective and pragmatic ones. So the types of equipment that we've used, at the Bowland Fells colony, we've used a fixed wing drone, so that's Alex there holding this EB, so that's about 1 metre wide. So it's different from the quadcopters we've seen used at the other sites. And I will say they fly much, much higher than Matt's examples. This one was actually flown at 85 metres, quite significantly higher than the 15-metre example. At the Belmont colony, a quadcopter was used, but again at a much greater altitude. So that one was at about 50 metres. So we've got 2 separate UAVs for the 2 separate colonies. So I'll start with the Bowland Fells colony. So this is the mosaicked image that the drone took. It's about 1 kilometre, just over 1 kilometre wide, this area. And you can see the orange plots that are superimposed to the mosaicked image. So these are monitoring plots that have been visited over the course of time through the traditional monitoring that's happened at the site. So a guy has gone in to the site and counted all of the nests within those plots for several years running. And so it enables us to look at different results that we get from the 2 different methods. So we've got overlap between ground-based monitoring and the drone-based monitoring in 6 of these plots. So I excluded this one because there wasn't sufficient overlap. This one's got about 95% overlap, so I did include that one. This is what Bowland Fells looks like from the ground, so it's a typical sort of British upland, heather moorland peat habitat. So this is how the ground-based monitoring works. They're half-hectare plots, and for this part of Bowland Fells, it's a sub-colony called Langdon Head. There are 12 of these. Density is worked out within the plots by walking up and down these transects, and then that's extrapolated across the whole of the area. So there are more of these for the other parts of the pSPA, the other sub-colonies, but there are 6 here, as I mentioned, we've got for comparison. So because of time constraints as much as anything, the image analysis was done by me. It's not automated, although that is a possibility, and it is something Matt's already talked about and colleagues of mine are looking at too. So I zoomed in to about 1 to 100, systematically scrolled through the imagery within ArcGIS and marked each of the gulls that I could see. So there were definite differences in these images compared to Matt's. So this is zoomed in to about 1 to 100, and this is an example of what a gull looks like at that resolution. So you can quite clearly see a white blob for the head and the grey feathers on the back, and often the mirrors on the tail with the primary sticking out. So in this image, there are, I think, about seven obvious gulls. Can't say whether they're nesting or doing something else. They're obviously individual gulls. So I've taken them to be nests, but that's an important thing to come back to in a minute. And that's what they look like when you zoom right in. So that's my search image. However, I also got quite a lot of this sort of thing, where you get a white blob. So there's obviously a gull down here, but you've got a white blob there and a white blob there. So I've no reason to think there would be a white blob in the middle of a heather moorland, but could be a rock, could be something else, could be a bit of litter. So I've marked these as possibles. So I've got a set of gulls I've confidently identified and a set that I'm not so confident about. So here's what the comparisons look like. So my expectation was, it's been hard to formulate a hypothesis really, but my expectation was we would have greater numbers of gulls counted from the drone, because we would be counting gulls which were not necessarily nesting, might be off-duty parents, might be non-breeders, might be foraging. My colleague's expectation was the other way around, that there would be lots of gulls not attending their nests, and so from the ground you would be counting nests, from the air, from the drone you're counting individuals. So that's one of the crucial differences. It's not a like-for-like comparison. The ground-based surveys are counting total nests, whereas what I'm counting is numbers of gulls. There isn't much of a relationship. Sometimes you get more from the drone, sometimes you get more from the ground. I then included the possibles, and it starts to look more like my expectation. We're starting to get more gulls counted from the drone imagery than we are from the ground-based, but it's not a perfect pattern. Still getting more gulls counted, or more nests counted from the ground in some situations than we are from the drone. So it's a bit of a mixed picture, to say the least. And some of the things that I've started to think about that we might need to look at are what happens if we compare individuals. So I said we're not comparing like for like. Would it look like more of a relationship if we were comparing individual gulls from the ground with individual gulls from the air? I'm also going to look at the mapping accuracy, because I'm not entirely convinced that those orange plots are all very accurately mapped, because they're not all half a hectare, some are smaller, and I definitely think we might get these edge effects, because even if you move this line out a couple of metres, you're including more gulls that wouldn't otherwise be so. And obviously there may be error. I may not, although I try to be systematic, I may not have picked up everything that was there, and obviously there are ways that that can be automated and should be. But I then started to think, is this even worthwhile? So we're thinking about the possibility of switching from one monitoring type to another. And that means we have to go to some lengths to understand what the differences are between the two methods. But at the scale that these plots are being covered at, what is the acceptable variation? So if you total up the total count of gulls observed from the drone with the total number of nests, they're within about 10%, 12% of each other. Would that be acceptable? Would we be able to live with that sort of variation? And is it even worthwhile looking at this? Should we just keep sending a person to monitor those plots for time immemorial? And actually, does this open up questions about monitoring and what we can do with drones? Because we could quite conceivably use that method for asking all sorts of different questions that we can't deal with on the ground. So obviously with a drone you can cover a wide area relatively quickly. So we could start to look at things like the extent of the colony, the distribution within the extent, the density of birds within certain areas that are subject to management, not subject to management. So might we actually be looking at just another tool really in our kit, rather than completely replacing everything that's gone before it? I don't know. One thing I will say is that like Matt and others have shown, we saw very little apparent disturbance in the imagery that I went through. Admittedly a small area, but this was one of only 3 gulls that I saw in flight across the whole 250 odd birds that I counted. So it seems like, albeit at a much greater altitude, we're not seeing disturbance either, which is good. Some of the other uses that my colleagues are interested in is things like habitat monitoring. They're also quite keen on thermal imagery, so this is an example of a bit of thermal data from the same mosaic image. They think they might even be able to start looking at eggs. I'm slightly dubious, but who knows? That's a possibility. So there are definitely many more uses to these drone images, as well as just being able to enumerate birds within it. Just quickly to show some data from that other colony, from the Belmont colonies. This is a black-headed gull colony. It's a much less complex background, and so it's much more straightforward to identify the gulls within it. You're either looking at birds in flight or birds on the ground. You're not trying to tease apart rocks and other sort of complex bits of habitat. And my colleagues have automated this and counted just over 3,000 birds in that image alone. And you can see that all that's left behind is the birds that are in flight and definitely not nesting. Again, it's a count of individuals, so the same questions still exist. So I think there's much more to do, especially in complex environments, and we probably need a fair bit more ground truthing. Obviously, image automation is a big thing, and Matt's making good progress on that. Colleagues of mine are also looking at the same thing, so there's potential there to kind of, bring this together and improve it as much as we can. So I just put a question about image resolution. I mean, the images, Matt, you had at low altitude looked really, really great. Obviously, these ones at higher altitude are not so great. A project that DEFRA are running at the moment with Andy Webb at HiDef and BTO to look at urban nesting gulls suggests that if we looked at higher resolution imagery, so these are 2 centimetre images, every pixel is 2 centimetres, the ones I showed you previously were 3 centimetres, there's maybe more of a chance of getting decent images that actually rule out a lot of those possibles. And I think also probably ID, which is something I didn't really cover, from these 2 centimetre imagery is much likely to be better. You can see here that some of the gulls nesting and flying much darker in shade than some of the others in the image, which suggests that probably herring gulls and lesser blackback gulls, whereas in the examples I showed you from Bowland Fells, seemingly uniform in their plumage. But I will say, like Matt, that there's very little evidence of disturbance, which is really encouraging for us, and it seems to be a very promising and powerful technique that we might be able to add to our kit, but I think there are questions about how we use it and what actually we're aiming to do with drones. Thank you.
Interesting. Any quick questions for
You used a fixed wing, right?
Yeah, for the Bowland Fells colony, that was the fixed wing, yeah.
Do you think that might be one reason why there'd be more blur, or is it solely altitude, or is it because they're moving past instead of hovering over the ground? And would it be different if you used rotary?
Yeah, I don't know, to be honest. It's not really my area of expertise, but yeah, it seems plausible that that might be the case. I mean, certainly the Belmont image from the quadcopter seems much sharper, but yeah, I don't know. That's one for the Earth observations people.
I think that might be a good avenue to go with as well. You combine that with how the image capture tech, the cameras sensors are so much more sophisticated than they were a few years ago. I think that would improve it as well.
Were you there when it happened, Alex? Do you think you would have maybe, it would have been easier making accounts if you'd have been there and knew the place a bit better?
From the ground?
Yeah.
No, I don't think so. I mean, the surveyor from the ground has been doing it for 8 years or more from the plots that have been going back for 15 years or so. So I don't think there's any problem with the total nest count. Those quadrats or those half-hectare plots are designed to count everything within them, and they're 5-metre spaced transit lines. So I think they're probably, as close to 100% as we could expect to get.
One last quick question, yeah.
So what was the timing of your surveys in the nesting season?
Yeah, the Bowland Fells, that's a good question. So the Bowland Fells flight was 15th of May, and the ground-based survey was 2 weeks later, so that was end of May, beginning of June.
About hatching time. I just wondered if, what the efficiency of the ground-based counters was. There's some evidence that there can be quite a high number of nests that are missed, particularly as the chicks are hatching and running under heather, that type of thing.
Yeah, no, I mean it's certainly possible. We think it's good because the transect is quite narrow, only 5-metre width. But yeah, there's always a possibility that some may be missed in a complex environment like that. And you're quite right about the temporal delay. So ideally, we would have liked those to have been closer. But it's effectively one surveyor doing all of those plots across the whole of the Bowland Fells. So I mean that's another consideration I think when we're thinking about using drones. It can be much quicker and cover much bigger.
They don't get tired so much. The electrons run out, even though they weigh nothing. Yeah. They do. Go on. Great. Okay. Now I just want to do a quick check. Is Andy Webb, has he arrived? Okay, Andy. Is everybody happy if we run over a little bit and grab coffee later on? Feel free to slope off if you feel like you're nodding off at any point, but I think I'm quite interested in what's going on and I'm keen to explore it. I didn't know we had Andy as special guest. I'll do an extra little 5-minute slot. He said he wanted to say a few little things, if that's okay with you, Kyle. And then maybe we'll be okay running kind of a little bit past 4 o'clock or so. But I think Kyle should feel free to continue in his full flourish and shouldn't feel constrained. Okay? Great. But yeah, do run away if you want to. Great. There you go. Say 5 minutes or so.
Okay, yeah. What I'll do is I'll go through this very quickly because it actually overlaps quite a bit with the principles that Alex was putting across. Same idea. What we're trying to do here is to do a census of the nesting common gulls in Aberdeenshire. I'm the regional organiser for the latest UK-wide seabird count. It's a very important area for common gulls. It's two of the largest colonies that used to exist occur in the region, including Kilcoyne Hills, which held 13,400 apparently occupied nests. But there's evidence of significant declines in the numbers of these colonies, and they've become fragmented. One of the colonies I wanted to focus on is one of the splinters of this Kilcoyne Hills. Is an area called Gallows Hill.
There are estimated to be about 1,000 pairs of common gulls nesting there by people doing casual surveys. It's an area of moorland used for grouse shooting. What we wanted to do was to minimise the disturbance from the visit, so we decided to use a drone to actually map the extent of the colony initially. We weren't convinced that we would be able to get enough detail during the survey to be able to count the number of nests, which was the ultimate goal of this survey. I just gave the whole job to Richard Humbidge of the RSPB, and I'd like to acknowledge his contribution to this this piece of work. He used a DJI Phantom Professional 3, kitted with a 12 megapixel camera. He flew it at 90 meters above ground level, and this gave an image resolution of 4 centimeters ground sample distance. I'll talk about it in general discussion about the whole principle of trying to sort out what your image resolution is, certainly from my professional background, being able to express in terms of the size of the pixel on the ground is very useful, and there's good ways of calculating it. He flew a grid pattern in which he obtained 70% overlap between the images in 2 dimensions, so that's a lot of overlap in the images. And what you'll see here is created an ortho-rectified image. So this is every part of that image has is geo-referenced. He used Esri drone-to-map software, which I've never come across myself before, but it produced a single geo-TIFF of about 3.7 gigabytes, which was quite good fun trying to transfer that between us. He covered most of the colony in a single day of about 6 hours, to give you an idea of that, and it's about 5 square kilometres in extent there. Give you an idea of the image resolution, 4 centimetres. This is less than I'm used to, or coarser than I'm used to dealing with in my own field of work, as Alex pointed out. You get the good, the bad, and the ugly. So that's an intermediate image, some relatively clear imagery compared to other bits, and these were, I was struggling even to tell whether they were common gulls or not. So on that basis, I continued with the plan, which was just to map the extent of the colony. And I did this by marking every single individual that I thought was a nest site, and did this just by creating a shapefile within ArcGIS. So these are all geo-referenced, these dots. And so this dot map shows you where gives you an idea of the density of these objects. They used it to create a low and high density grid for subsequent sampling. So what we did was plot-based counting. This was putting a stick on the ground at a defined spot and creating a radius of 5 meters around the stick. This is the type of technique described in the Walsh et al. Guidelines for doing surveys. I actually did some work which I forgot to include, which was to estimate how many of those dots would occur within 5 meter radius plots. So I just wanted to make sure there weren't likely to, there was a reasonable probability of actually detecting reasonable numbers of birds within each of those plots, which I was very glad I did. If I'd gone, sorry, that's 500 meters, that should be. Am I right in saying that? No. 5 meters. Yes, it's 5 meters radius. Okay, and So within those, we counted the number of occupied and unoccupied nests and the level of occupation by the number of eggs and chicks that were present. And we did this right at the very end of May, which is the peak time for nesting activity, just as they're starting to hatch. So here you can see the low density stratum, the green area, and the red area, which is the high density stratum, and these are the number of apparently occupied nests, and are the green dots, and the open circles are the empty plots. So there's actually a very low density of occupation within the low density stratum, and much higher in the high density stratum, which is what we wanted to do. The image on the right shows the level of occupation compared to what the drone footage showed, which is the closed dark red circles. And to give you an idea of what came out, there was a density estimate and an estimated number of apparently occupied nests within the two stratums. There was an area that we just decided to count total number of occupied nests, where we could look over without excessive disturbance. And the interesting thing there is that the casual counts of about 1,000 pairs at the colony was quite a big underestimate compared to what we were able to estimate using this approach. So just to give you a little bit of a follow-on from this, we have actually looked at another colony. There was no disturbance, as you can imagine, from what Alex was saying, at 90 metres. We also flew the drone much lower over another colony. Haven't had a chance to look at that. Again, no disturbance, but at 45 metres, this gave a 2 centimetre ground sample distance. And I'll certainly be attempting to see if I can come up with an estimate of the number of nests and compare that with some ground-based counts for that particular colony. So that's it. Thanks very much.
Thank you. So a third species of gull now, it seems relatively fifth maybe if you count greater blackbacks.
Yeah.
It seems fairly tolerant. Any questions for Andy? Okay, shall we get Kyle out? I guess you're a kind of unofficial plenary again, aren't you? Because you're wrapping up the main conference, right? Are you?
That's right, yeah.
Yeah.
I'm bookending, right? And I have my tan hat on here. I just need shades and a shirt, right?
Oh, yeah. I'll go and get it for you tomorrow. Yeah. If you're middle-aged. Okay, some water there if you'd like it. It's just we don't have a pointer. It's just using the forward and back arrows, if that's okay. Yeah. And it might be worth putting this on. I think now there.
There, that's better.
Is that better?
You can hear me?
Yeah.
Great.
Aircon started coming on. So. All the time in the world.
Okay, great. Well, it's really nice being here. I think of going to a workshop on using drones and seabirds like 3 years ago or something, and it seems like we've advanced so much since then. I mean, it's really neat to see the automation of counting, different drone types being used. It feels like we're really moving. Today I'm going to talk about some work that we did trying to count cliff nesting seabirds. So it's very similar to stuff that Robin was talking about. We used just a kind of off-the-shelf commercial drone, so all of this will be with a DJI Phantom. So we wanted something that a biologist could use. So I mean, all this footage was basically taken by Emil, who is a master's student, so he was able to do that himself. We didn't have to get a commercial pilot or anything, and this was all done in Canada, where the rules are a little bit different. They're a lot vaguer than they are here. You have to get an SFOC, but you don't have to necessarily be a pilot. On the other hand, the province of Quebec for 3 years refused to give out any SFOC, so it would be kind of nice to have the system like you have in the UK and the US, where it's kind of a little bit more clear about what you need to do or not do. Okay, just first off, I just want to thank the two people I've been working with, Dave Bird, who's been doing a lot of drone work in Canada, and Emile, who's a master's student that did a lot of the actual work. And Dave asked me to do a plug for his journal, so he's editor of this Journal of Unmanned Vehicle Systems. So if you're thinking of some place to send your work, consider this journal. It's a hybrid open access, so it's free if you don't want open access. If you want open access, then there's a cost, there's a fast turnaround, and they've had a special wildlife issue recently and a special geomatics issue. So I think we've already talked about this in some detail, but the future of UAVs in research is driven partly by public perception about UAVs. So certainly a lot of perception by media, and I think also regulators, people at Environment Canada or Canadian Wildlife Service or the equivalents here in Europe, kind of this idea that drones are somehow evil, and which is one reason why I'm trying to use this term UAV rather than drone, because when you think of drone, you think of, I don't know, Star Wars and the military and so forth. And a lot of paranoia about the invasion of privacy, safety issues, terrorists, and again, permitting likely remains the greatest hurdle in Canada. I mean, the science is there, but actually getting the permit to do a lot of this seems to be the biggest hurdle. So I guess there's a lot of concern in terms of people that are regulating things in parks. They want something that looks like this, not with one of these there, right? And there was recently a tourist that was banned for life from Kruger National Park for using a drone. I think we all know this here. With some advantages of drones or UAVs, initially more expensive, but now cheaper in the long run. You can fly at lower altitudes at night, potentially. There's better data with the imagery, perhaps the draping or merging of images, less obtrusive to wildlife and more green overall than using plane surveys. They can carry many kinds of sensors, and number one, they're safer for humans. The number one cause of fatality of biologists in Canada is vehicle crashes. Okay, so just a little review of some of the, a few different projects which have tried to count birds with drones. So some work by Dave Bird there working on goose flocks. And I think we've seen some of this already with gulls today. Very similar, I mean, quite easy to count the geese using drone technology. And this is all now being automated, so you can just send up the drone, take the photos, and count the number of geese. Another good example with terns, sea turtles, raptors. There's some data from 4 different raptor nests that we flew over, and different species. And we could have had 100% success with revisits, but I think very high success at determining the number of young in these nests. And there's some pictures to give you an idea of what it was like. But, and I'm going to get back to this in terms of the seabirds as well, there's some issues with the raptors attacking the drone. And I've been surprised to hear so few issues today with seabirds. We've had quite a few issues with gulls attacking the drone. Okay, so this is what we're trying to do. We'd like to be able to census a colony of seabirds like this one here, a colony of murres. So these often occur in very remote areas. They can be dangerous to get to. It can be dangerous to fly up to the Arctic and either do this aerially with a plane or do it by boat. We've had at least 3 fatalities trying to count murres in the Canadian Arctic. So we went out to Gull Island in Newfoundland. So this is the first study site here on Gull Island. So this gives you an idea of the MERS that we're trying to count. Just idea of what we're doing here. So we have the terrain. It's very windy, so we could only work in a very limited number of conditions. It was kind of 1 day in 7 that we're actually able to go out and work. First off, just kind of a note on the imaging requirements for counting MERS. So we wanted to have some idea of how far away we need to be in order to be able to resolve individual birds in a situation like this. So we use these 2 different criteria, the Johnson criteria and the TTP criteria, with 2 different types of cameras, a GoPro and a Sony. And you can see there's 2 different criteria, a little different, but to detect, to know that there's something there, you could be as far away as about 40, anywhere between 30 and 50 meters, depending on the type of camera and the criteria in there. To actually classify, to know that they're MERS, you'd be looking more between 20 and 33 meters, and then to count between 13 and 7 and 33 meters. So you see that with these kind of off-the-shelf drones, you really do have to be relatively close to be able to count something as fine scale as a colony of MERS. So in terms of fly-past effects on the MER colony, we monitored the colony during fly-past. We looked at the behavior of the birds, observed how many birds were leaving, estimated the percentage of colony disturbed by the UAV, observed relatively minor disturbance on the colony in 2015. There were no losses of eggs or chicks, but there were birds which would fly off, primarily non-breeders. So this is an example here. This is before the UAV, and this was after the UAV. And you can see that there's quite a number of birds which have flown off and moved off their eggs. And the biggest problem was that if some of them flushed off, a gull would come in and grab the egg. So we had about 10% loss in 2016 with these surveys. So we stopped doing. We ceased doing the surveys there at Gull Island. And another issue is here's the UAV. There's a herring gull, and I took down our this particular UAV. Just went in, knocked it into the water, and it flew off seemingly unharmed. But that was it for the UAV. Okay. So things didn't work out very well in Newfoundland. I think one of the big differences in Newfoundland is that we had, well, first off, there were a lot of gulls around, but also that there were eagles going through the colony and picking off MERS. So there was already an aerial predator that was, taking a few birds every day. So we tried this out in the Arctic. One of the main differences in the Arctic, in terms of disturbance, was a difference when, so here's a plot with primarily non-breeders. And so this is from a blind, and you can see as the UAV. So this is just footage from a drone, from the blind. And you can see the number of birds which flew off as the drone approached. I realize it's not the best quality footage. And here's a case where there's only 10% non-breeders, so they're primarily breeding birds. And you can see that basically nothing happens. So there seemed to be a strong difference between the reaction of the non-breeders. So if you have a plot where there's a lot of non-breeders, where you get these flights of birds where a few fly off and then they all fly off. They seem to react quite differently than where you have a plot of just breeding birds. And we tested out different distances and in terms of takeoff distance from the birds, and then also the distance at which we flew past the bird. And we also compared chicks versus eggs. And none of those had a strong effect. The only real difference was between plots with non-breeders versus those with with many non-breeders versus few non-breeders. So you can see here that in terms of the UAV counts versus the ground counts before the UAV arrived, you can see that the UAV counted more birds where there were few non-breeders. So because it was able to see into areas of the cliff that we couldn't see from the blind. And there's also somewhat of a time of day effect. You can see that the ground counts actually did better because there were some non-breeders which would fly off where there were many non-breeders, and where the cliffs were very sparse with few non-breeders, the numbers were pretty much the same. Overall, though, there's a strong correlation between the two sets of counts. So these are the fixed plot counts that Environment Canada has been using for over 40 years now, and this is how population numbers are gauged in the Canadian Arctic. And so these are the number of birds counted by sight on the x-axis, and the number counted with the drone on the y-axis. You can see that there's a strong correlation, but that the drone tended to count somewhat more birds than were counted by sight, at least at these very high numbers. And that's excluding any site, any plot which had a large number of non-breeding birds. So in other words, for instance, the K ratio, the correction factor between the number of birds present in a plot and the number of breeders was somewhat higher for the drone, but it actually might give a more accurate count because it flushes off some of those non-breeding birds, and what we're really interested in is number of breeding pairs.
Kyle,
yeah.
I think this is a good moment. Can I just pause the recording we're doing now and then start another one?
Yeah, sure.
At 1:20 it's going to stop.
Oh, okay, yeah, sure.